Greetings, my young math Padawans. This is lesson 4.4, Factoring Polynomials, Part 1. That's right, just when you thought we were all done with factoring, there's more, way more. As a matter of fact, I have a lot of steps that we're going to use for factoring a polynomial, and it all basically boils down to how many terms there are. How many terms there are in the polynomial will determine kind of the method that we take to solve. Whether there's 2, 3, or 4 terms, it's going to kind of dictate exactly where we go with each of these problems. I would pause the video right now. I'd make sure that you had these 3 steps kind of written down. Maybe the shortcut rules that are over here on the side as well. It's not a bad idea to have those around, although we will give you a couple of examples of what this looks like. But pause the video now. Make sure you have these 3 steps written down in your notes so that you can refer back to them until you get really comfortable with what's going on. So pause the video and write that down. So for this first section, we're going to focus first on step 1, looking for a GCF. And we're going to practice a couple examples that have GCF factoring involved. And that's really the most important thing that you want to always look for with the problems is you want to see, is there something that I can divide into all 3 of the terms? So is there? Yes, there is. Did you say x, that you could divide an x into it? Yeah, you can divide an x into it, and then you're left with x squared plus 10x plus 24. So let's throw those steps from the previous slide back up here. So in this process, we've looked for a GCF and we found one. So now we're going to count the number of terms that we have left over, and we're going to look at each one of the factors individually. Now, the GCF's here, so we're not going to look at here, but inside the parentheses, we have 1, 2, 3 terms. So according to the process here, we go to part B, say if there's 3 terms, we look for a shortcut rule. Okay, not sure what that means here, but look, we can factor the quadratic-like equation. So can we think of a pair of numbers that multiplies together to give me 24 and adds together to give me 10? 6 and 4 works. So that means that this quadratic that's in that parentheses can be factored down even more. And what I have here is my final answer. Now, we're just going to make sure that it's factored down completely. So let me just check. Nope, can't factor x anymore. What about x plus 6? Can I factor x plus 6 more? No. What about x plus 4? Nope, that's all done. So, is it factored completely? Yes, it is. So I am done the problem. This will be my final answer. So x to the third plus 10x squared plus 24x can be factored down to give me x times x plus 6 times x plus 4. And if you want to, what you can do is you can check your answer. Right? You can check your answer. You can say, okay, let's go ahead and multiply that out and see if I get it. So I'm going to just multiply these 2 first. So that'll give me x squared plus the outsides and the insides and the lasts. It gives me x times x squared plus 10x plus 24, and I'll distribute my x. And check it out. I get the original problem that I started with up there. So that does, in fact, check out to be correct. Let's do another one together. So we have 5y to the 6th power minus 125y to the 4th. Let's get our steps up here to look at them quick. So according to my steps for factoring a polynomial, I should look for a GCF first. So let's see here. Is there something I can divide into both of these terms? Yes, there is. I can divide a 5. But wait a minute. It's more than 5. I also can divide out some y's. Like, let me see here. I got y to the 6th here. I got y to the 4th here. I can factor out 4 y's, 5y to the 4th. When I do that, what am I left with? Let's see here. So if I divide out that 5y to the 4th, factor out the 5y to the 4th, I'm left with y squared minus, let's see here, 125, that's 25. So I got y squared minus 25. Okay, let's keep looking. So that's the GCF. Let me check out. Can I factor down y squared minus 25 more? Looks like I can. Okay, so I got 2 terms. So 2 terms, look for a shortcut rule. What I'm talking about here is this is the difference of 2 perfect squares. Remember that shortcut back from the first slide? Right? It said that if it's in the form a squared minus b squared, or a perfect square minus another perfect square, that I can rewrite it to be a plus b times a minus b. That's what I got going on here. I got two perfect squares with y squared and 25. So I can rewrite that. So let me write that 5y to the fourth out front. Then y squared minus 25 turns into y minus 5 times y plus 5. That would be my final answer to this particular problem in its fully factored form. Because I can't factor y minus 5 or y plus 5 anymore, so I'm all done. Again, I could check myself by multiplying that out if I wanted to, but I'm just not going to with this problem. So one more example here together. Can you see the GCF? Let's see if you can do this one on your own. So pause the video. Maybe you can do it real quick. Maybe we can do it step by step together. See if you can pull out the GCF in this problem. Yeah, it's 6. So we got z squared minus 4z plus 4. And now I'm left with this quadratic to see if I can factor down this quadratic more. And yes, I can. The pair of numbers that multiplies together to give me 4 and add together to give me negative 4, right? If you're doing that x, you'd be looking at it like this. What are the two numbers? Negative 2 and negative 2. So I can factor that down to be z minus 2 times z minus 2. Oops. That would be the final answer for this problem. All factored completely. Now, you could also write that as z minus 2 squared if you wanted to. Either answer is correct. So at this point, why don't you pause the video and give these 4 problems a try. See if you can factor them completely based upon the 2 things that we just talked about. So go ahead, pause the video, give these a try. All right, now that you've had enough time to try these out, let's do them together. So I'm looking here at number 4. I'm going to look for the GCF. I'm going to see that I can factor an x out of that. Did you get in your second step, x squared minus 7x plus 10? And then we can factor that down even more because I can think of a pair of numbers, again, if I'm thinking of that x box, the pair of numbers that multiplies together to give me 10, adds together to give me 7, negative 7, that's negative 5 and negative 2. So I can factor it down more. All right, what about number 5? Is there a GCF? You bet there is. 3n to the 5th power. Then I can factor out and I'm left with an n squared minus 25, which, if you remember from the previous problem, I can factor down to be n minus 5 times n plus 5. That would be the final answer in this particular problem. Number 6, 8m to the 5th minus 16m to the 4th plus 8m to the 3rd. What's the GCF? Let's see here. What can I divide into all 3 of those terms? 8m to the 3rd power. And what am I left over with? Let's hear. That'll be m squared minus 2m plus 1, which I can actually factor down more to be m minus 1 times m minus 1. Again, if I did that x thing like I did on the previous 2 problems. I could write it like that, or I could write it as m minus 1, that quantity squared. Either of these would be counted as correct, so take your pick. Which way do you like it the best? And last but not least, number 7, 4x to the 4th plus 8x to the 3rd plus 38x squared. What can I factor out? Look for the GCF. 4x squared. What am I left over with? X squared plus 2x plus 8. I'll make sure I got that thing factored down completely. And I cannot, wait a minute, there's no numbers that multiply together to give me 8 and add together to give me 2. Numbers, so it could be 1 and 8 or 2 and 4. None of those add together to give me 4. So guess what? I'm actually done right here with that answer. There's nothing else that can be done. Part of knowing when you're done factoring is exactly that, knowing you're done factoring. That comes with some experience and with some practice. All right, so let's take a look at another one of these shortcut rules, focusing here on these 2 shortcut rules right here. So let's take a look. So you have something called the sum of the difference of 2 perfect cubes. So you remember how we were looking at perfect squares before? Well, these are perfect cubes, and I've created a list for them here. And that's 1 to the 3rd, and 2 to the 3rd, and 3 to the 3rd, and so on. I can create that list of perfect cubes, and they're really helpful to be able to recognize those pretty quick, because when you do, you can look at this like x to the 3rd plus 27. It becomes pretty easy to factor. You just kind of got to fill in the formula, fill in the shortcut. So for this problem, I'm really looking at this first rule. This was the guy that I'm looking at because it starts off with a to the third plus b to the third. And that's what I got going on here, a to the third plus b to the third. So because of that, I'm going to be able to factor it out to be, and again, I'm looking here, that's my a value is going to be x, and my b value is going to be 3. So when I fill in the shortcut, I'm going to write a plus b, so that's x plus 3, and then a squared, so x squared, minus a times x, or a times b, which is in x times 3, so 3x, and then plus b squared. Well, 3 squared is 9. Now here's the good news, is when you use this shortcut rule, that's done. You can never factor that anymore. It'll be finished and it's pretty much done provided you've pulled out the GCF first. That's kind of the big thing here. Let's look at the next problem. 8x to the third minus 125. Again, if I'm looking at this problem, right? I'm looking at this problem. Let me see if I got perfect cubes. Do I have perfect cubes? What's here? 8x to the third. Yeah, that's 2x to the third power. And then I got minus 5 to the third power. So I definitely have the difference of two perfect cubes here. And if I'm looking at this problem, this is actually that second shortcut. And I know that because it's a to the third minus b to the third. So I can simply fill in my formula. Again, my a value is going to be 2x, and my b value is going to be 5. So, okay, so I'll have a minus b, and then I'll have a squared. Now check this out. You got to be careful. 2x, that quantity squared. And then plus a times b plus b squared. Okay, now I know I wrote that out there, but that's because I wanted you to see this. I want you to remember that when you have a quantity squared, you have to make sure you raise both of those things to the inside, to the second power. So 2x, that quantity squared, actually turns into 4x squared. And then I'll do the math there, and I'll get plus 10x. And then 5 squared, of course, is 25. So there's my final answer, factored down as much as I possibly can factor it. So with these problems, it's pretty much just looking for those perfect cubes and making sure you use the shortcut rule. So go ahead and pause the video right now. I will warn you, don't forget the very first step. Don't forget step 1 when you're going through these problems. So pause the video right now. Give these 4 problems a try. All right, let's take a look at these 2 problems now. So I have x to the third minus 64. So first I'll look for a GCF. There isn't one in this particular problem. So let me see, is that the difference of 2 perfect cubes? And 64, let me think about that. Yeah, that's 4 to the third power. It was in my list. So I have my a value, right? There's a, and that's going to be b, and I can just go fill in the shortcut. So for this one, it's a minus b, so x minus 4. And then you have a squared, so x squared, plus a times b, that'll be 4x, plus b squared, which is 16. All done. Final answer. For number 9, same thing. It's x to the third plus, let's see here, 216. Hey, that's 6 to the third power. So again, there's my a, there's my b. I'll fill in the shortcut rule. I have a plus b times a squared minus a times b, which is 6x, plus b squared, 6 squared, which is 36. Let's try 11. So 6 into the 5th minus 750 n squared. This is what I was talking about. Make sure you look for the GCF first. Is there something that you can divide into both of those things? Yes, there is. You can divide a 6 n to the second power into both of those. So when you do that, you'll be left with n, not m, n to the third minus 125. And then when I look on the inside of those parentheses, again, I'll recognize that that's n to the third minus 5 to the third. And I have my a value and my b value right there. So don't drop the 6n squared. That's got to be there. But then we'll write the rest of it. So it'll be a minus b, so n minus 5 times n squared plus a times b, 5n, plus b squared, 25. So this whole long thing is the solution to number 11. What about 10? Let's take a look at 10. Is there a GCF? Yes, there is. Negative 2x squared would be the GCF. And that means I'm left with 8x to the third plus, watch that negative, 125. So I got 2x squared. And then if I look at that, that's 2x to the third plus 5 to the third. And there is my a value and my b value. So here we go. 2x squared. We'd have a plus b. We'd have a squared, and just like we talked about last time, that's 2x, that quantity squared. And then it'd be minus a times b plus b squared. Okay, let's write it one more time. Final form, 2x plus 5, 4x squared, minus 10x plus 25. There's the answer. All right, folks, that's all I got for you today. So good luck with these problems. We'll try a couple more of these out, and we'll take it from there. See you later.